Okay, guys, I'm gonna go through the 2017 and 2018 exam paper. So we're obviously gonna start with question 1 to 4, which is the easiest one. I'm just gonna work our way through till question 20. I'm just gonna record myself doing the whole thing. Yeah, so this is the one that's on Moodle. It's the last one listed. I'm doing this one because all the correct answers are outlined, so I definitely know I'm correct. So, yeah, um, we're gonna go through it, and let's just start. Okay, so this is question 1. If we randomly select a participant from this sample, what is the probability that he will have an attained score greater than 74 on the test? So we're going to write out our information here. So let me just grab this marker. So the average score attained by 16 adults, so n equals 16. On a novel psychometric test is 82, so the sample mean is 82. With a standard deviation of 8, so I just got all that information from the question. And it's normally distributed. Okay, so that's all the information we need. So the question asks for greater than 74. So I'm just gonna draw out my graph here. Just a normal distribution. Then in the middle, so we know our mean is 82. And we know our standard deviation is 8, so 82 plus 8 is 90. And then here is 98. Then 82 minus 8. Embarrassingly, I'm gonna have to fucking do that on the calculator. Wait. Okay, so 82 minus 8 is 74. And then 74 minus 8 is 66. So basically, the reason I did that is because the standard deviation is the spread. How spread out are the scores on this? So like one standard deviation away from the mean is 90, and one standard deviation below the mean is 74, and so on. So this is 0, this is +1, this is +2, this is -1, this is -2. So in this case, the standard deviation is 8, so like -1 is like -8 one time, so that's why it's 74, 66, and so on. So this question asks for greater than 74. So 74 is here, and it's -1 standard deviations away from the mean. So we're looking for all this area here, because that's all greater than 74. So according to the normal distribution, I'll just draw out another one here just so that we know the percentages. Yeah, well, that's shit. But anyways, we'll go 0, -1, -2, and then 1 and 2. So 1, 1. Yeah, so basically this area here, so obviously half is 50% because the full thing is 100%. So half of this is 50%. Both of these equals to 68%. So then half, so like just one here would be 34%, because 34% is half of 68. So we're looking for half this. Then we know from this, we know that this is 34%. And then half is 50%. So if we add these two together, we get the probability of a participant in this study getting a score greater than 74. So the answer then is 50 plus 34, which equals 84%, which is the correct one on question 1. So this is for question 2, which asks, what is the probability that the randomly selected participant score will lie outside the range of 66 to 98? So we want outside the range. So there's our 66 just here, because I have the same graph, because obviously the same information. And then I have 98 there. So we're looking for outside of this range. So all of this area here and all this area here. So another thing to keep in mind about percentages of normally distribution is that -2 standard deviations to +2 standard deviations, all that is 95%. So from here to here, all inside this range, that is 95%. The probability of getting a score within -2 and +2 standard deviations of the mean is 95%. So obviously that leaves over 5%. So if we divide 5% by 2, that would mean, because obviously there's two sections we're looking for, that would mean that there's 2.5% here and 2.5% here. So the answer then is 5%, because there's a 5% chance that a person's going to get a score in these two little bits here. So that's the correct answer on question 2. So for question 3, it asks about the confidence interval. So the 95 confidence interval for this data is, and then lists all the options. So for this, I have made a mnemonic. It helps me. I know some people don't really like them, but that's okay. But it helps me remember the order to do the confidence interval. So my mnemonic is Sam doesn't take milk. So S is standard error, D is degrees of freedom, T is t-value, and M is margin of error. So that's just how I remember to the order. So we'll do step 1, which is standard error. So the formula for standard error is S over the square root of n. So we can calculate that. So the standard deviation is 8 over the square root of n, which is 16. That is, I'll just calculate that. So that equals to 2. So the standard error is 2. Then we have step 2, which is degrees of freedom. The formula for degrees of freedom is n minus 1. So that is 16 minus 1. You don't really need to know this for the exam, but I found it helped me understand what degrees of freedom was. Degrees of freedom is how much more data can we use to find out how much freedom. So after you calculate the degrees of freedom, so that's obviously 15. Then the next bit is the t-value. So that's step 3. So to find the t-value, we need to go to the graph on the exam paper. So the graph that you need is just down here. So the question is obviously asking for the confidence interval. We know that it's 95% confidence, so that leaves us with 5%. So we need to remember that. So we need to go down to this one here. So selected critical values of the t-distribution. And we find number 15. And then we go across up here is 0.05, so that's 5%. We go down to 15 and then all the way across to 2.13. And then that should be our t-value. Just here, yeah, so it just mentions it here. So 2.13, that's definitely correct. So I've just written it down here. So you go to your graph, you find 15 because that's the degrees of freedom, and then you find 0.05 because you're left over with 5% in the 95 confidence interval, and then you're left with 2.13. So that's step 3, just to find the t-value, which we now know is 2.13. Our last step then is the margin of error. So we'll go to step 4 then, sorry. So the formula for the margin of error is t multiplied by, I think it's 2 secs. I just have to double check. So it's t multiplied by the standard error, which we already calculated, it was 2. So using this formula, we know our t-value, so 2.13 multiplied by 2. Let me just do that. So 2.13 multiplied by 2 is 4.26. 4.26. So then we need to construct the confidence interval. So we do the mean, which is 82, plus minus 4.26. So we know then that it's D, because that's the right one. Okay, so question 4 is a theory question. So it asks, what effect does a decrease in confidence level have on the width of a confidence interval? So to explain this, I'm just going to say that a confidence interval is a range of numbers we use to guess where the true answer is, or like the true population average, because obviously this is just a sample, but if we were trying to guess where the true population average is, then we're basically outlining a range where we're guessing what the true average is. So the confidence interval is the range, and the confidence level then is how sure we are that the answer is in that range. So that's where your 95%, 90%, that's where that comes in, saying we're 95% sure that the true average falls within the range that we've outlined. So basically the question asks, so if we decrease the confidence level, what effect does it have on the confidence interval? So basically if we decrease the confidence level, if we decrease the percentage, if we decrease how sure we are, what happens to the range? Does it increase or decrease? So basically, if we are more confident, we have a bigger range, because obviously it's more likely that the true average is going to fall inside a bigger range. But if we are less confident, then we have a smaller range, because it's less likely, because there's less numbers to choose from then. So it's less likely that the answer is going to fall in a smaller range. That is why the answer in this question is decrease, because if we decrease the confidence level, if we decrease how sure we are, then the confidence interval also decreases, because we are less likely to have the true average actually in that range, if that makes sense. Question 5 is another theory question. So it's asking what the standard error is. The standard error is how much would the sample mean change if you repeated the study again and again. So if you were to do the same study over and over, would the sample mean be the same almost every time, or would it be different every single time? So if basically what standard error is, according to this definition in the question, if you took the sample means from doing the same study like repeatedly over and over, and then put all of those sample means on a distribution, the standard error would be the standard deviation of that distribution that you made by pulling the sample means by doing the same study over and over. If there is a small standard error, the sample mean will be the same every time, because the standard error is small. But if there's a large standard error, the sample mean will be different every time you do the study, because the means of error is larger. The chances of making an error is larger. Basically, that's what that means. So then the answer to question 5, this will be the same for every time. It is the standard deviation of the sampling distribution of the mean. Question 6 is another kind of theory question. Using just the provided information, the probability of making a type 2 error for this test is, so basically all you need to know for this question is a type 1 error is the significance level that's mentioned in the question. So if question 6 asks for a type 1 error, it is referring to this percentage that is mentioned in the question, so the significance level. So if this question was asking for type 1, the answer would be 5%. It's always going to be 5%. He's always going to use 5% in this question. If it's asking for a type 2 error, like it is in this case, it's always going to be not capable of being directly worked out. So a type 1 error is when the null hypothesis is true and you reject it. So this is when you are saying that there has been a change, but there actually hasn't been one. So you're saying that there has been a change. So the null hypothesis says that there is no change, but with a type 1 error, you're saying that there has been a change, but the null hypothesis is actually true and is saying that there actually is no change. So the type 2 error is when the null hypothesis is false, but you fail to reject it. So basically that there has been a change, so the null hypothesis is wrong in saying that there isn't a difference. And you're saying that, and you don't reject it, basically. So you're saying that there hasn't been a change, but there actually has been one. So that's question 6. So for question 7, it's asking for the test statistic of all this information up here. So we're going to start by writing down information from the question. So a study of Irish learners, so N equals 25, taking their first driving test, found the average number of driving errors committed by these learners was 6.5. So that is the sample average, 6.5, with a standard deviation of 2. So S equals 2. And a large EU study of the driving test results estimated the European mean of learner driver errors to be 7.4. So that is the population average is 7.4. And then significance level is 5%. Okay, great. So that is all the information that we need from this question. So we're looking for the test statistic. So the test statistic basically is how far the sample mean is from the population average measured in standard errors. And we know that standard errors are tells you how much the sample mean would change if you repeated the study again and again. So that like margin of error, basically how the difference between the sample mean and the population average measured in standard errors. So basically what we need to do is we need to find the difference between the sample average and the population average and then divide it by standard errors, because that's basically the unit of measurement, standard errors. So therefore the formula for test statistic is the sample average minus the population average over the formula for standard error, which is S divided by the square root of N. So we can calculate that. So the sample average is 6.5 minus 7.4 all over 2 divided by the square root of N, which is 25. So I'm just going to calculate that on the calculator. So I just calculated that. So I got minus 2.25 from this formula. And if you go back to the question, the answer is minus 2.3. So basically he's just rounded it up. So yeah, that's how to do question 7. Sorry, I forgot to change the number. So question 8 asks for the critical value. So we have done this before. So the critical value is the cutoff number that tells us if our sample result is extreme enough to reject the null hypothesis. So from the previous question, we found that our test statistic was minus 2.3. So basically we want our critical value will basically be our cutoff point to tell us if minus 2.3 is outside of the range, and therefore we can reject the null hypothesis. So to do this, we need to find the degrees of freedom. So df equals n minus 1. N we know is 25, so 25 minus 1 equals 24. And then we go down to our table again, because it is a 5% significance level as mentioned in the question up here. We go down to our our table, and then we find 24, and then we go up to here, which is 0.05, and then if we go over, it should be 2.06. So let me just check if that's correct. Question 8. Yeah, so 2.06, that's the right answer. So that is your critical value. So basically we're in the question 9. It's asking, where is question 9? Do we have enough evidence to reject the null hypothesis? So are we able to say that there hasn't been a change? Yeah. So are we able to reject, I fucking find the null hypothesis so confusing. So we are basically asking, are we able to say no to the fact that there hasn't been a change? So we're saying no, there has been a change. So in this case we want to reject the null hypothesis. So basically we found our test statistic, which is minus 2.3. We have our critical value, which is 2.06. So to find this out, I always draw like a range. So you put minus 2.06 on one side and then plus 2.06 on the other side. We're looking for where on this range does minus 2.3 fall. So minus 2.3 would fall somewhere behind minus 2.06, because if 0 is in the middle here, then obviously minus 2.3 is going to fall outside of the range. So when rejecting the null hypothesis, we do, if it's outside the range, you can reject the null hypothesis, but it's inside the range, then you can't reject the null hypothesis. So outside the range, reject. Inside the range, don't reject. Basically, is what the null hypothesis is. So in this case, because it's outside the range, we are saying yes, we do have enough evidence to reject the null hypothesis. Okay, so this is when it starts. This is when I think it starts getting hard in the well, the whole thing is kind of tricky, but this is when I think it starts getting a little more complicated in the exam paper. So question 10 to 16 is the ANOVA test. So basically, ANOVA is asking how different are the three group averages from each other, and how much like variance explains the difference in scores. So variance is how different the individual scores are. So basically it's asking like how different are the actual results, like not in relation to variance, if that makes sense. So like that you can't put down to chance just because the results, the people's scores are like very different. That probably doesn't make sense, but that's kind of how I've been understanding it. So these are the three groups. So the first question is asking the model sum squared score is. So to calculate that, you need to find the means of these three groups, which I'm just going to do now. So you have a control, low, and high. This is in relation to dosage. So control is obviously like standard, and then low dosage and high dosage in a performance pill, I think it is. I didn't really read the question, but to find the average, then I'm just going to calculate all the averages. So basically you divide the sum of all of them by 1, 2, 3, 4, 5. Okay, so I just got the averages of all of these different groups. So the next step is you need to find the average of the three averages of the groups. So the total, like the grand average is what I call it. So you're doing 4.8 plus 5.4 plus 7.2 divided by 3. That's what I've been doing, so let me just do that. So I just did that there and I got 5.8. So 5.8 is the grand average, and then 7.2, 5.4, and 4.8 are the group averages. So the next thing you have to do to find the model sum squared is this formula. You need to input the figures into this formula. So the formula is the sum of n multiplied by the group average minus the grand average squared. So basically you do this formula for each group. I'm just going to write that out quickly. So you're doing this for each group. So like, for example, the control group, you would do 4.8 minus 5.8. So 5.8 is always going to stay the same in this. And then n is always going to stay the same in this because n is 5, because there's 5 participants in each group. So you're doing 5 multiplied by the group average, so either of these, and then minus 5.8 squared. So you're doing that 3 times for the 3 groups. So I've just written out the formulas there. So we're still the same numbers. So control 4.8, low 5.4, high 7.2, and then x grand is 5.8. Have the formula up here. So control, so n also equals 5 because again 5 participants. So control is 5, and then you're putting in the control average that we calculated, so that would be 4.8. Low is 5.4 and high is 7.2. So you're going to calculate all these. So I have calculated all them. So we have 5, 0.8, and 9.8. So if we go back to our formula, we need to calculate the sum of all of these, and that's going to be our answer. So what we do then is we add all these together to get the sum of the SSM, so for the averages. So the model sum squared, so basically the squared averages, the sum of those. That's what the question is asking. So we're going 5 plus 0.8 plus 9.8, and that equals 15.6, which is the SSM. if we go up here and check, yeah, it's 15.6. So that is how you do it. I know it's long and there's a lot of steps, but once you do it a couple of times, it is grand. It's easy enough. So for question 11, it's asking you to find the residual error sum squared. So it's different from the model sum squared. And the difference is the SSM, so the model sum squared, is looking for the variation between the means of the group, so the overall group means. But the SSOR, which is what we're looking for in this question, it's looking for the variation within the group means. So variation between group is SSM, and SSOR is variation within group. So basically, this is asking us, it is asking us how far each person's score is from their own group mean. So basically, this participant here, how far is this participant that got number 2 away from the group mean? So for this question, we've already calculated this, but we need the means of each group. And then also the overall group mean, which we also need to, oh no, sorry, we need the overall group mean. That's what we need. And then we obviously need our scores as well. So basically this one's a bit longer, but I think it's easier. Basically, this formula for this is the sum of the score minus the group mean squared. That's what we need to do. So we need to repeat that for each group. So we're going to start with control. So we're looking at the participants here. So we have a 2, 8, 5, 6, and 3. So if we go back to our formula, it's the score minus the group mean. So the group mean for control is 4.8. So we do 2 minus 4.8, 8 minus 4.8, and so on. All of them minus 4.8. So I'm just going to calculate all these and find the difference of all of these. So I just calculated the difference. So you're ignoring like the minus signs and the any minus signs, you're ignoring them because we're just specifically looking for the difference between them. So we don't need the minuses or anything. So if we look back to our formula, we need to square these. So we're going to square the differences. I'm just going to do this and then I'll calculate that. So basically, I'm after just finding, I'm just going to go through it from the start. So you're looking for your participants here. So 2, 8, 5, 6, 3. Taking away the group mean, which in this case is 4.8. Then you're finding that difference, you're squaring that difference, which I found here, and you're adding all of the results of the squares together. So you repeat that for each group. So again, the formula, sum of the score minus the group mean squared. So you're repeating that for all 3 groups. I'm just going to do that. I found this one here. So 22.8 is the sum of control. I'm just going to do that, find the sum of this, and then we'll move on. So after doing all that, I got control 22.8, low 9.2, and high 6.8. If we go back to our formula, it says the sum. So we're adding the 3 of these together, and when you do that, you get 38.8, which when we go to our question is the correct answer. So that's how you do question 11. So this is question 12. So question 12 is asking for the test statistic value, and because this is ANOVA, it doesn't use the standard test statistic formula that we used in question 7. So basically we're looking for an F value here. Don't ask me what that stands for because I have no idea. So basically the F value is the difference between groups over the difference within groups. So remember I explained the difference between SSM and SSOR. It is basically SSM over SSOR. But I will try and write some notes on this because I'm not 100% sure why. But I've created a form. I found this question really hard, so I created a formula for it. And it works. So basically it's SSM, which we did do in the question, divided by K minus 1 all over SSOR divided by N minus 1. So basically these are degrees of freedom. I don't know why you need to put these in. I will write notes on this, but this is just how to do question 12. This is the formula that I've been using and it's been working, so it's grand. So K in this case stands for the number of groups. So regardless of the question, so obviously K is always going to be oh sorry, I just wrote it down wrong. So basically it's N, oh my god, sorry. It is SSM K minus 1 and SSR N minus K. I will write notes on this because I do not get this question, but basically this is the formula. K is the number of groups. K is always going to be 3 because we have 3 groups: control, low, and high. So if you want to change that to SSM divided by 2, you can. I can rewrite it. And this one is always going to be 12 because N is 15 in this case because we're combining the 3 groups. So I got 15 from 5, 10, 15. So really the formula for this question is SSM that you calculated divided by 3 minus 1, which is 2. And then SSR divided by 12. That's basically it. That is the formula. It's always going to be that. But yeah, unless he changed the amount of participants, which I can't really see him doing. I don't know why he'd do that. But in general, it's always going to be 2 and 12. So that's your formula for this question. So we calculated the SSM and SSR. So SSM equals, I just need to go back and remember what it was. So SSM was 15.6 and SSR was 38.8. So if we go back to our formula, we can do SSM, which is 15.6. 15.6 divided by K minus 1, which is 3 minus 1, over 38.8 divided by 15 minus 2. I'm just going to calculate that and then we'll get our answer. So after calculating that, I got 2.41, which when we go to question 12, he basically rounded it down. So it's 2.4, so that's the correct answer. So for question 13, it's asking for the critical value. The critical value in this case, we're looking for the degrees of freedom again. In this case, the formulas for the degree of freedom is K minus 1 and N minus K, the same ones that we were using for the previous formula for the F value. So basically the same numbers that we calculated, 2 and 12, it's always going to be 2 and 12. You're going down to this graph here. This one here, so the F distribution, because we're looking for the F value. You're finding 2 up here and you're going down to 12. And the answer is 3.8853. If you go back up, where is it here? Oh wait, yeah, 3.89, 3.88. So he just rounded it up. Yep, so that's the answer for question 13. So for question 14, it's asking about the null hypothesis again. So basically same system that we did for the previous question. Our test statistics 2.4, which we calculated, and our critical value, which goes on the range, is 3.89. So 2.4 would fall somewhere, I guess, here. So that means it's within the range. So if it's outside, we say yes. But if it's inside, we say no. So in this case, we don't have enough evidence to reject the null hypothesis. So our answer to question 14 is no.